Hi, I'm Catherine, and I'm with Portrait Displays. When calibrating a display or validating its color accuracy, one of the most important values in determining a display's ability to correctly reproduce colors is something called Delta E. Delta E is a number that tells you how different two colors are from each other. It's a way to measure how close a display's color output is to the color it should be showing under a defined display standard. There are many different formulas of Delta E, and you'll see a variety of versions in the Calman software. The two main ones that you will see is Delta E2000 and Delta ITP. Delta E2000 is the metric that we use to assess perceptual differences, typically for SDR content, and Delta ITP is what we use to evaluate perceptual differences for HDR content. Their differences come in how they predict the perception of the human visual system, where SDR presumes a certain set of conditions, and HDR covers a wider range of luminances, and that changes how human perception responds to those different luminance ranges. So we have two different metrics to help pick up on those sensitivity differences in our human visual system. A Delta E of 0 means a display is perfect. There are 0 differences in the accuracy of the colors it's producing compared to their actual real-world values. A Delta E of 1 to 2 is excellent. The difference is almost imperceptible to the human eye. A Delta E of 3 or above will have a visible error. Most people will see something is off, and there is a noticeable difference in the display's ability to reproduce certain color values. If you're a filmmaker, graphic designer, or photographer, you want the colors on your screen to be accurate. Otherwise, you're making decisions based on an image that isn't technically correct, and the content you're delivering won't match your creative intent when viewed on another display. If you're a gamer or a film enthusiast, having a color-accurate display ensures you're viewing content the way the creators intended. Delta E makes this color accuracy measurable. When you calibrate a display with Calman, it measures hundreds of colors: reds, greens, blues, skin tones, shadows, and highlights. And for each measurement, Calman compares your screen's output to the target values defined by a standard like Rec 709, P3, or BT 2020. And for every single measurement, Calman calculates a Delta E. This allows you to see areas where your display might be deficient. It also allows Calman to calculate the adjustments needed to correct those deficiencies and improve the accuracy of the device you're calibrating. With the advent of HDR, a newer color difference formula has been developed called Delta ITP. So what's the difference? Delta E was created mainly for SDR color spaces like sRGB and Rec 709. It works well for lower brightness ranges, and it assumes the human eye responds to color differences roughly the same at all brightness levels. Delta ITP is designed for HDR content with larger color spaces like BT 2020. It accounts for brightness up to 10,000 nits, and it models human perception more accurately in very bright and very dark scenes. Delta E is great for SDR content, but Delta ITP aligns better with how humans perceive differences in brightness and color at high luminance levels, making it more accurate for HDR content. Without having a way to quantify a display's performance, calibration would be guesswork. But Delta E and Delta ITP are tools we can utilize to measure a display's accuracy against defined color standards and ensure that we're calibrating with precision and purpose. Validating a display's Delta E or Delta ITP gives you an easy-to-understand measured value that assesses its color accuracy. If you found this video helpful, please give it a like. And if you're new here, please consider subscribing. Thanks for watching, and we'll see you on the next one.